In this video, we're going to go over local maximum, maxima, and absolute maximum. And then the same for minimum and minima. So I have pictures to kind of illustrate rather than definitions. But your local maximum is the highest point. And then when you have local maxima, that's just plural for maximum. So now I have two. I could have three, I could have four, but this is just the plural version of maximum. Now, when we're talking about the absolute maximum, it is the very top of that graph. Not every graph is going to have an absolute maximum or minimum. Okay, but if there's the very, very top of that graph and nothing goes above it, then it's the absolute. Here you can see in those local maxima that in this local area here, this is the highest it goes before it starts decreasing. And here's the highest it goes before it starts decreasing. But local maximum only has the one. And then same thing for minimum, minima, and absolute. This means one, this is plural. So in this local area, here's the lowest point. In this local area here, this is the point, this is the lowest point. But this right here, the absolute, is the lowest that this graph ever goes. When we care about max and mins, we're focusing on the y's. We do sometimes care about the x, but what we're really focusing on is those y values. Pause this if you need to so you can get it all copied down, but here we go. Use the graph to find the numbers, if any, in which f has a local maximum. What are the local maximum values? Okay, so the graph is the lowest. Just keep using the highlighter. Oh, it said max. Well, okay, here's the local mins. And here is the tippity top max. So max in purple. Min in pink. Okay. So when I have my maximum here, I really care about this y value, but we'll also state where it is happening. So at x equals 0, the local max is 3. So be the same thing. Okay, what are the local mins and what are those min values? Okay, well, I have 2 here. Now, luckily for us, the mins are the same, they're 0. So we can say at x equals -2 and x equals 2, the local mins are 0. Let's pretend like these are different values. We'd have to say at x equals -2, the min is 0, or the local min is 0. And at x equals 2, the local min is, let's say, -5 if it was different. But they're the same, so we can all write it on the same. I'm so sorry, guys. Okay. So same thing here. All right. Where's the max? Where's the min? So here's my local max. And for the record, this is not the absolute max, because this is going to keep going up and it's going to go above this. So it is a local, it is not the absolute. So for part A, at x equals pi/2, the local max is, and that max is the y value, is 1. And then for my local min, which is here, at x equals negative pi over 2, the local min is my y value, negative 1. Oops, and you can't read any of that.